Okay, so for this activity, you're going to need another sheet of patty paper, and you'll need your compass. And I want you to use your compass as your straight edge because we're going to be using the measurements along the side with this specific one. So let me make this large for you. We're going to start off just drawing a straight line parallel to the edge of our paper here, our patty paper. I'm going to name this line with a lowercase scripted m with a subscript of 1 because we are going to draw a second line. Now the second line I want to be 3 centimeters away. So I'm going to use the measurements here and go out 3 centimeters and draw a point. And I'm going to do that a second time because I need 2 points in order to draw that second line. So now that I have 2 points, I could simply join those 2 points together for my parallel line that's 3 centimeters from my first one. And I'm going to name this line with a lowercase scripted letter m again, but the subscript of 2. So those 2 lines are 3 centimeters apart. Now to the left of line M1 and kind of close to that line, I'm going to draw a triangle. Now with the triangle I'm going to draw, I don't want my longest side to be, I want it to be less than 3 centimeters long. So again, I'm going to use this as kind of my gauge here, and I don't want my my longest side to be 3 centimeters long, so I'm going to make it clearly shorter than 3 centimeters. And then I'm just going to draw a shorter side here and connect those. And again, you can pause this video as I'm going to have to do because my lights went out. Okay, so I'm just going to connect those 2 sides together for the third side of my triangle. I'm going to label those vertices with capital letters, as always, for points A, B, and C. So we just drew triangle ABC, close to line M. These are parallel lines 3 centimeters apart. Okay, so what we're going to do is we're going to fold the reflection of this triangle across our first line. So just like we did with the point, I'm just going to fold my paper along line M1, crease it. I'm going to flip it over so that I can see the original triangle through the patty paper, and I'm just going to trace it. All right, so when I open up my paper, I can see my tracing there, the reflection of triangle A, B, C. Now these points, I don't want to label A, B, and C again. They're different points. So the way that we show that they are different is by using those prime symbols. So this is going to be A with an apostrophe, and we read that as A prime. It's the image of A. This would be B prime, and this would be C prime. Now we're going to fold M2, and we're going to trace our image triangle, not the original one. So I'm going to fold along line M2. I can see triangle A prime, B prime, C prime through the patty paper, so I'm going to trace it. And you can use your straight edge here if you'd like to. I'm just kind of going over it really carefully. And so when I open it, there's the image. And I'm going to label this one with prime notation as well. This time we use 2 apostrophes, or quotation mark would be another way of reading that. That's A double prime, B double prime, C double prime. And again, that's called prime notation, just to show that these are different points, but that this is the image of that. This is the image of that. Okay, so we have our drawing all ready to go. We're going to make a couple of measurements. So we're going to measure the distance from A to A double prime, B to B double prime, and C to C double prime. And we're going to measure in centimeters because remember we measured the distance between our parallel lines to be 3 centimeters. So we did that in centimeters. I'm going to use my centimeter side of my ruler, and I'm going to measure from A to A double prime, my second image. And I can see that that's exactly 6 centimeters. I'm going to do from B to B double prime. And I'm going to measure that, and that is also 6 centimeters. What do you think C to C double prime is going to be? I bet it's 6 centimeters. What do you bet? And it is. I'm going to go ahead and connect those segments that we just measured. So I'm going to connect A to A double prime, B to B double prime, and C to C double prime. All right, now that we have our drawing all ready to go, we're going to answer some questions. And again, feel free to pause this anytime you need to get caught up with those drawings. All right, so here is the same drawing that we just got finished making. And I'll bring this to the center for you. So we just made the same drawing, but it's always good to do hands-on and get those practice in with those paper foldings. So number 7 says, how did the size and the shape of triangle A double prime, B double prime, C double prime compare to those of the original triangle ABC? Well, is the size of the triangle the same? Yes. Is the shape the exact same? Yes, it's exactly the same size and shape. So they are the same shape and size. In other words, we could say triangle ABC is congruent to triangle A double prime, B double prime, C double prime. Because remember, the definition of congruence just means the same size and the same shape. So we're using that definition to say those triangles are congruent. Let's look at question 8. What do your measurements tell you about the reflected images of A double prime, B double prime, and C double prime of the vertices A, B, and C? So it's wanting to know, what are these images? And I'll go here on our sheet here. I want to just check our first answer. Both triangles have the same size and shape, which is what we were saying. And I think that what happened on number 8 is it's slightly read differently than what's on the notes. What do your measurements tell you about the segments connecting the vertices of triangle ABC and that of the triangle A double prime, B double prime, C double prime? So we just measured those. We measured those segments, A to A double prime, B to B double prime, C to C double prime. And we found that they were all 6 centimeters. So I'm just going to write that here. A to A double prime was 6 centimeters. B to B double prime was 6 centimeters. C to C double prime was also 6 centimeters. So in other words, A to A double prime equaled B to B double prime equaled C to C double prime. If we wanted to use the congruent symbol, then we would put the segment bar above those. I would put a segment bar here with the congruent symbol. Segment bar, congruent symbol, segment bar. But if I don't use the segment bar, I'm talking about their measures, and so I am just going to leave that congruent symbol off. Let's go back to the question on the board here, and you can just double check that they were all equal distances. That's what we were saying. How does the fixed distance between pre-images A, B, and C and the images A double prime, B double prime, C double prime compare with the distance between the two parallel lines? Okay, so remember, we measured the distance between our parallel lines to be 3 centimeters, and then we measured the distance between A and A double prime, B and B double prime, and C double prime to be 6 centimeters. So the distance between A double prime and B double prime and C double prime were all twice the distance between our parallel lines. 6 centimeters is twice that of 3 centimeters. So this was 3 centimeters apart, and our original point and our final point were all 6 centimeters apart, so twice that distance. Okay, so let's look at our notes here, or on the notebook. It tells us that triangle ABC, the original triangle, and triangle A prime, B prime, A double prime, B double prime, C double prime have the same relative position of points, and we call that the orientation of those points. Now, a good way, it tells you in the second paragraph, to think of orientation would be to think of your hands. If you look at your left and your right hands, they are not oriented the same direction. If you were going to count from your thumb to your little finger on your left hand, you would have to go counterclockwise to go from thumb to little finger. On your right hand, to go from thumb to little finger, you'd have to go clockwise. So those are not oriented the same. So these two triangles are oriented the same. If we went clockwise, we would go from the A to the B to the C. These two triangles, however, are not oriented the same. If we go clockwise, on this one we go ABC, this one we go ACB. So these are not oriented the same. These, however, are oriented the same. So that's all orientation means. So let's fill in the blanks for question 10 in your notes. And it's highlighted on the board here. It says, therefore, a translation of a shape is a composition of two what? Two reflections across what type of lines? Parallel lines. So your blanks on your notes, you should have reflections and parallel lines. So let's talk about what that means, okay? So we're getting a definition of a translation from this original triangle to the final triangle. I'll do it on this picture. I think it might be a little clearer. From this triangle to this triangle, it's just a slide, which we call a translation in correct mathematical terms. So a translation was created by doing a double reflection across parallel lines. So that's one definition of a translation, a double reflection across parallel lines. Now the word composition that is used there in that definition, all composition, if you think of doing a composition in an English class, it just means you have several paragraphs. You have the opening, your body, your closing. Composition in mathematical sense means a sequence of two or more mathematical operations. So, for example, the expression 2x plus 1 is a composite expression because you have to do two things. Multiply the x times the 2 and then add 1. Well, in this case, this is a composition because it took two transformations. It took two reflections to get the translation. That's what the composition word means there. All right, so let's wrap that up. So suppose a figure is reflected over each of three parallel lines. This will generate three images of the original pre-image. So imagine we had a third parallel line here, and we reflected A double prime, B double prime, C double prime across that. The question is, if we did that, then which image pairs represent translations? Well, we already know these two represent a translation. We would have a fourth figure here. So the first and third would be translations. Now imagine this triangle flipped over another line. It would be oriented the same as this one. So the second and fourth image would also be a translation. So your first and third would be a translation, and your second and fourth would be a translation. All right, on your homework tonight, you're going to need 2 sheets of patty paper. You'll need them for number 1 and number 2. So I want to make sure you have good directions on that. You're going to trace this figure and this line. And then you're going to do the paper folding just like we did on our lesson today. And so your actual number 1 is going to be on patty paper. You're not going to see the reflection on your homework. You're just tracing this on the patty paper and doing the reflection on the patty paper. So don't lose your patty paper for number 1 and number 2. They are your work. You won't have anything showing on the paper here itself. All right, have a great day.